Today, we are going to focus on Trimline development, which is a free add-on function in AnsysForm. But to showcase it, first, we need to set the environment. I've just launched AnsysForming, version 2024 R1, and I'm going to start by selecting a new project. You can adjust the save location, but I'm going to just leave cold forming and the unit system alone. For Trimline development, under the Process tab pull-down menu, all we need to do is use the Advanced tab and select the option for Trimline development. Now we can go back one tab to Operations, and since this is a Trimline tutorial, add our trim operation. We can add operations using right-click and Insert. After having an appropriate number of stages, we can adjust each operation using the drop-down menu. We will change our first operation to blanking, as when a trim operation is the first operation, it is called blanking. For following trims, the trim/pierce option should be used. To delete any operations, the subtraction symbol can be used. Now we can start by importing our original trimline, target product, and our tooling meshes. After selecting Import in the top right, we're going to bring in the original trimline and product lines as curves. Importing these two will show them in the display window. The goal is for our initial blank, this blue outline, to match our target, this orange outline. Unfortunately, for this situation, our target line is a solid. We need to get the middle surface of this outline, because simulations are based on the middle surface. For this example, I've already done work in a CAD software to obtain a curve of the middle surface, so I will import a curve, which I've titled Target Line. The visual display can be used as a verification that you have the right line. Now we need to bring in all the tooling meshes. To bring the tooling meshes, we will need to expand the miscellaneous menu and add them using the plus sign. In this example, we have the blank mesh and tool mesh from a previous tutorial. Once these are imported, we can close the import window. But now we need to define the blank materials, and tools. To do this, we will use the blank pull-down menu at the top and follow red highlighted entries to populate the model. We begin by selecting the red Select option, where I have to specify to pick by mesh instead of curve. Then you can pick from the display screen or the part menu. I've named my files to make this easy, but you can always toggle the display to pick the correct part. Make sure to apply and close. Next, to define the material, we have a material file. So after selecting the red Material option, instead of using the AnsysForming library, you can select Import Material option in the top left and select an appropriate material file. Once selected, you can briefly view the material information. Make sure to select Save and Assign. For the blank thickness, the entry is shown in the rightmost column. For this example, you can see it's 1.0. Next, we need to define the trim line in the blank operation and define the tools in the draw operation. We go to the Operations pull-down menu and see our two operations, our blanking and our draw. Let's define the blanking operation first by ensuring B05 is selected. We define our trim line by selecting the Add button under Trim 1 and choosing our line. Next, to define area to keep in the blanking operation, we select the red None entry, then need to select a point or node inside the trim line. Selecting a point on our blank outside the trim line would keep only the outside. After closing, now it's time to define our tools in the draw operation. We continue by selecting the draw operation, D10. To define each tool, we simply click the red highlighted entry followed by the red Select option and pick the mesh from either the part list or the display window. For our die, we hit Select and then choose our red part. For our binder, we hit Select and then choose the blue part. And finally, for our punch, we hit Select and choose the teal or aqua part. Finally, we need to select the gear in the top left to define the tool offset. For this case, we already have an offset, so I can select the Already Have an Offset option, apply, and close. Now, we go to our Advanced Pull-Down tab to define our target line. Select the red TRT line option that says None and pick the yellow target line. Close and select the checkbox Then ensure the Dev option is green by toggling it. This ensures that this is the line that will be developed. Now we are ready to run the simulation, but if we want to verify the tool motion looks correct, we can use the Positioning tab back in the Operations pulldown under Operation D10 to view an animation. To actually run the simulation, we only need to select the Runner option. Select Start and it will begin. On this page, we can see that there are 2 iterations set up automatically. The number of iterations can be adjusted by changing the tolerance in the Advanced pull-down menu. Looking at our runner, we can see that the first iteration already met our tolerance. But to check the result, we close and return to the Advanced Trimline Development tab and select View Result. Upon selecting View Result, by default, we will see the initial drawn trimline compared to the target line. The target line is shown in gray, with the initial draw shown in green and red, where our red is out of tolerance. If we want to see the initial trimline before draw, simply check the box titled Show Trimlines. As our initial draw was out of tolerance, we can choose the next iteration by using the drop-down menu. In selecting iteration 1, we can view that our newly developed trimline is all within tolerance. We can additionally view the changes made to the blank by toggling the initial blank curve in the display tree. AnsysForming is an easy, efficient to use tool that in just a few minutes can be used to get a very accurate trimline for your product.